Alright, so this time we're going to solve inequalities. Now, it's basically almost the same with solving equations. However, in solving inequalities, the inequality symbol changes whenever you divide or multiply by a negative number. So, to illustrate, let's have this. 4x plus 3 is greater than or equal to 6x minus 2. If we're going to solve this, that becomes 4x minus 6x. And then you have greater than or equal to minus 2 minus 3. So 4x minus 6x, you get negative 2x. Greater than or equal to negative 5. So we divide by negative 2. X this time becomes less than or equal to 5 over 2. Observe, what if instead of transposing 6x from the right side to the left side, I transpose 4x from the left side to the right side? So our equation becomes 3 plus 2 is greater than or equal to 6x minus 4x. That is 5 is greater than or equal to 2x divided by 2. 5 halves is greater than or equal to x. X is less than or equal to 5 halves. 5 halves is greater than or equal to x. Notice the direction of the point. It points towards x. That's why we have to reverse the inequality symbol whenever we divide or multiply by a negative number to maintain the truthfulness of the inequality. Alright, so that's the first thing you need to remember. Now, what if you are dealing with absolute values? So let's just say we have the absolute value of 3x minus 4 is greater than or equal to 5. Again, take note that the absolute value is either the value or the function or the expression inside the absolute value is greater than or equal to 0 or less than 0. So first, assume that 3x minus 4 is indeed greater than or equal to 0. If that is the case, 3x minus 4 is greater than or equal to 5. So that's 3x is greater than or equal to 5 plus 4. 3x is greater than or equal to 9. X is therefore greater than or equal to 3. Now, what if 3x minus 4 is less than 0? From the property of absolute values, that becomes negative of 3x minus 4 is greater than or equal to 5. So that's negative 3x plus 4 is greater than or equal to 5. So negative 3x, that's 5 minus 4, negative 3x, 1 divided by negative 3. X is therefore less than or equal to negative 1/3. So there are two possible directions for the answer in this problem. If we want to graph in order to visualize, if this is 3 and then somewhere around here is negative 1/3, it says here in the first value x is greater than or equal to 3. So from here it moves towards there, that direction. It also says that for this to be true, x should also be less than or equal to 1/3, negative 1/3. So from there, it goes there. Alright? So all numbers greater than or equal to 3 and all numbers less than or equal to negative 1/3 would make this statement true. Anything in between will make it false. Okay, what if we have a quadratic equation? Or a quadratic inequality, I should say. Let's say we have x squared minus 5x plus 4 is, let's say, greater than or equal to 0. Again, just like with how you would solve a quadratic equation, this time we also apply factoring. So this is actually x minus 4 times x minus 1 is greater than or equal to 0. So x minus 4 greater than or equal to 0 gives us x is greater than or equal to 4. X minus 1 is greater than or equal to 0 gives us x is probably greater than or equal to 1. Now, which among these two would be the correct solution? Let's assume a value greater than 1 but less than 4. So let x be equal to, let's say, 2. We substitute it here. Will it give us a value greater than or equal to 0? Let's try. 2 squared minus 5 times 2 plus 4, is it greater than or equal to 0? That gives us 4 minus 10 plus 4. 4 plus 4, 8 minus 10, negative 2 is not greater than or equal to 0. So meaning, the answer or the solution to this are all numbers greater than or equal to 4 and 1. All numbers greater than or equal to 4 and 1. Take note, it says there x is greater than or equal to 1. So 2 did not work. Let's try 1 just to see. Let x be equal to 1. So 1 squared minus 5 times 1 plus 4, is it greater than or equal to 0? So 1 minus 5 plus 4, 1 plus 4 is 5 minus 5, 0 is greater than or equal to 0. So our solution set, actually, we're going to graph our solution set. If this is 1 and then this is 4, 1 is included and then all numbers greater than or equal to 4 are included. So I hope you're clarified with how to deal with inequalities.